All right, let's solve a system of equations using a TI graphing calculator. The sort of system that I'm going to work on is the kind you would get using a process of partial fraction decomposition. This is a technique that's used in calculus to solve certain integrals. The reason I'm choosing this is because these systems will always have a solution. I have an older video up on my channel that goes through all the possibilities of systems that don't have solutions or have infinite solutions. All right, but this is particularly for this type of system of equations. All right, so I have a system of equations on the board right here. And again, pretend that came from this process. What you want to do is take the system of equations and turn it into a matrix. Right, and you do that by removing the coefficients, or by removing the variables and just writing the coefficients. And then over here, the right-hand side of the equation. And that's what we're going to input into the calculator. All right, so I'm going to turn my calculator on. Right up here above the x to the -1 key, you'll see the word matrix. And so I'm going to go second matrix. Now what I want to do is edit a matrix. So I'm going to move the tab over, and I just need to pick one. I'm just going to pick the first one. And the first thing it asks me to do is to dimension the matrix. The dimensions are always rows, columns. All right, so the number of rows that I have in the matrix is 3 because I have 3 equations. All right, the number of columns I have in the matrix is 4. I have 3 variables plus the right-hand side. And once I put that in, you'll see a 3x4 matrix pop up on your screen. All right, now what I need to do is enter the elements of the matrix. I need to enter all these numbers in. So what I'm going to do is I'm just going to start in the upper left-hand corner here with the 2. And every time I hit enter, you'll see it move to the right. So the next one is 3, -1, and then 2. And then when I hit enter here, it'll go down to the first line, the first element of the second line. And I answer the second equation's coefficients, 1, -2, 1, and 4. All right, and then the third equation's coefficients, 5, 4, 2, 1. All right, just double check to make sure that you entered everything right, because if you make a mistake here, you will get the wrong answer. All right, so everything's correct. All right, now I need to exit out of the editor, otherwise it's going to think what I want to do next is supposed to go in a box, and it's not. All right, so I go back in, and this time I'm going to go to math. Now what we want to do is take this to row-reduced echelon form, which is the matrix you get with 1s on the diagonal and 0s everywhere else. It can be done by hand, but the larger the matrix is, the harder it is to do by hand. All right, so the calculator has a function. If I go up from the bottom here, RREF, row-reduced echelon form. All right, so I'm going to pull that onto the home screen, and now I need to tell it which matrix I'm using. So I'm going to go second matrix again. This time I'm going to stay in names. The one that you dimensioned, you'll see the dimensions next to. The rest of them are blank. All right, so I'm going to put A in there, and I'm going to close my parentheses. Now, the thing about doing these types of systems of equations, when they come from a partial fraction decomposition, is they are almost always fractions. It's rare to have a problem where the numerators of the partial fraction decomposition are not fractions. All right, so since I want fractions and not decimals, I'm going to go into the math menu and choose the very first thing, basically telling it to give me my answer as fractions. And that's pretty much it. Just hit enter. And what I get is now this. All right, so if we take this over from If we take this over to the board here, what I've just done is transformed this matrix into row reduced echelon form, and then that's not a 0. And the numbers that I have now on the other side will be the solutions that I need. All right, so it is 55 over 21, negative 13 over 7, and negative 7 over 3. All right, so the way you read these is this. This first column represents the variable x, second y, third z. So if I'm going to pull this out, I'm saying 1x, x, equals 55 over 21. All right, the second column is now 1y equals negative 13 over 7. And then the last column is z, so I have 1z equals negative 7 over 3. All right, and that is your solution to the system of equations. Again, it's a very particular subcategory of systems of equations in that they will always have a solution. There will be times when maybe one of the variables is 0, all right, but it will always have a solution.